In this video, we're going to look at our second example of using the formulas from section 5.4. We've previously done a video on this second equation, which helped us find the payment necessary to pay off a loan. In this video, we're going to look at this first formula, which is the present value formula of an annuity. An ordinary annuity. So what we are seeing in this problem is that P is the present value. This is evidently what you'd like to find. What you need to know in this problem is an R value. R is the amount payment that will be made out of an annuity. I is this interest rate over a certain time period. N is the total number of payments that will be paid out over the time period. So let's look at a typical example of this formula. And what we have here in this example is a gentleman named Jim Riles who is in an accident and has sued the parties involved, and the insurance company is going to agree to pay him $600 per month for the next 7 years. The question is, the insurance company, how much do they need to have on hand now in the present so that they can make the payments over the time period. So maybe the court has, as part of their agreement, has enforcing or making sure that the bank sets aside the money now so that they can pay Jim over time. So the bank needs to prove that they have the money to do the payment schedule. So this is the kind of question where this first formula will come in handy. So let's take a look at how we would complete this. All you need to do to find the p-value is to know an R, an I, and an N according to this formula. So R is the $600 that they're going to have to pay every month, the insurance company. R is the 0.047. This is the 4.7% annual interest, because the way this insurance company is going to raise money is they're going to set aside some money and then put it away in an account that earns 4.7% interest. This is what they've found. They're going to compound this account they're going to put money into is compounded monthly, so M is 12. And therefore the interest rate per month that this account they're going to put money in is earning the 0.39%. That is the interest rate they'll get per month. The question is, how much do they need to put away now to have on hand now to pay Jim off over time? So that's simply a use of this formula right here. So we will put our R value and we will multiply by 1 minus 1 plus the interest rate the monthly interest rate I, okay, and we need to raise that to the negative n power, and negative n is, or n is how many payments they are going to make out over this time period. So it would be a negative number according to this formula, and they're paying out every month for 7 years. So that'd be 12 times 7 payments. Okay, and we need to take that number and then divide it by the interest rate I. Okay, let's see if I have my parentheses matching up. Okay. It looks like I do, so I would say check on that formula. So this is the amount that the bank would need to have on hand now, $42,000, $877 point, say 44 perhaps, if we're rounding, okay? Now, that could be the end of this problem. How much does the insurance company need to have so that they can make the payment? So let's continue on a little further in this problem. So this is how much the bank would need to have, okay, and prove to the court that that they have the money on hand to settle the statement. Let's look and see, for instructional purposes, to see how this plays out over time. If you want to look and see how this plays out over time, that's called an amortization table. And we can see here, play this out over 1, 2, 3 payments perhaps. So after the first payment, what we're going to see is this is the amount of money that the bank or the insurance company has set aside. Now, every time they make a payment to Jim, it is going to be of the $600 variety. So they're going to pay $600 every time. Okay. Now, they're going to be raising that $600 in a variety of ways. They've put this money away, 42877.44. That account, that dollar amount, right, is going to be earning interest per month. It's going to be earning the I% interest per month. And just like our first video, put a dollar sign here so that because the interest rate is always going to be in cell B4. So if they had $42,000 put away, this is how much interest they earned in that first month. And therefore, the amount of money that they need to come up with, out of cash from some other location is the $600 minus the amount that they got for free. So they're needing to come up with the $432, and $167 of it, of the rest of the $600 came from interest on this account that they've set up. And therefore, what happens is they will have the $442,800 minus their principal. So their principal went down only by $432 because they got $167 for free from interest. So if you continue on with this process, right, by the drag and drop method in Excel, because we have set up our Excel document pretty well, we can see here that as the second payment rolls around, they got a little less money from interest because their amount in the account has decreased, so they're getting less from interest, which means they're having to come up with more money out of pocket to cover that less interest. But if you add these two numbers, they rise to the $600. Okay. Now we know that because this was paying out over 12 times 7 months, 12 times 7 is 84. So if you continue this process for, the cool thing about Excel is you can just drag and drop down to the 84th month. Whoops. Let me fix that, sorry. Should be dragging that down to the 84th month. Okay, so I just highlighted the pattern and drag and dropped it down. Okay, so there's 84 months. Now let's look and see how this plays out over time. They paid Jim $600 every month, right? And so they paid him for the $600 every month. There's 84 of them, okay? How much did they, were they getting from interest? Okay, because their account was earning interest every month. Okay, and we will continue dragging these formulas down, and then we will draw some conclusions from them. Okay. Almost done here. We need all the columns to be in before the numbers will make sense. So I'm dragging down to the 84th. Okay. Now, let's take a look at what we have here. So in a typical, what we can see here is that the original $42,877 that they put away, we can see that this amount is getting smaller and smaller over time because they're paying Jim $600 every month. Okay, so this amount is going down. But the dollar amount is only going down by this column. It's going down by $456 this month, $458 the next. And then the rest that the bank is getting is interest on the previous bank amount. Okay, so we can look to see here that, and as the bank amount goes down over time, because the account that is set aside is almost depleted, you can see they're earning less and less interest every time, and therefore they're having to come up with more and more out of their own pocket. Okay. So if you look and see here that the total amount that they paid, the total amount paid that let's say Jim was paid, right? That was the 600 times, let me see, it was 12 months for 7 years. So he was paid a total of $50,400. Okay. So how much did the bank or the insurance company have to come up with total out of pocket? Okay. Well, you just need to add up. Let's add up this column. Let's add up the amount that they had to come up with to this amount. This should be a colon here. They had to come up with the 42,877 of the 50,000, and the rest, this was the amount that they got for free, in a sense, from interest. Okay, because they thought ahead and set up this account, they got this dollar amount to this dollar amount in interest, and we should put a sum in front of that. And so this plus this should equal the 50,400. So essentially, by thinking ahead, they had to come up with less money because they set up an account that earned them $7,500 of interest, and that's how they paid Jim, with 42,000 something out of pocket and 7,500 free money from interest from thinking ahead. So that would be a complete solution to this problem, setting up an amortization table and using the formula to find the thinking ahead amount, essentially how much do they need to come up with in the present. And that would be the end of this video.